I'm Simon. I'm the head of technology at Conjure. I got an Android background myself. Conjure is a digital product agency. We help our clients bring their ideas to life to innovate from product design, UX, UI design, and mobile development, as well as web development. And I would like to share with you some of the projects that we did the last years. In 2021, 2022, we developed Aura, which is an electric vehicle fully powered by Android Automotive. This on the left side is actually a picture. It's not a render. This is an actual photo showing the cluster image and the IVI, both running in Android Automotive. Pretty cool project. Might do some talks around that another time.
Cool.
We've built an Android Automotive radio application for Radio Player, one of our clients. But it's not just automotive that we do. We work with many different companies. So yeah, it's really exciting. On the left side, you can actually see the same cluster display, but here displayed on a mobile phone, self-stabilizing. Yeah, so you saw the broadcast radio app that we built, and this is probably where my interest in radio comes from and why I'm doing this talk today. And it's about broadcast radio on the WIM3 reference board. And WIM3 used to be a reference board, at least. I had a look at the documentation in Android today, and this came up. So there used to be quite a long page about 3 or 4, maybe even 5 different reference boards and how to set them up. Now there's just this. I don't know what's going on. If someone knows more, I'd be interested to hear about it in the Q&A session, maybe. But yeah, that was probably, well, that was definitely the idea to use a reference board, because my expectation was if it's a reference board, then it should be straightforward to at least get Android running. Turned out in the end there were a few problems, but I'll come to that a bit later. First, broadcast radio. What is broadcast radio? I don't want to claim that I'm an expert. I'm an Android developer, right? But broadcast radio is about transmitting audio via radio waves, broadly speaking. There is different frequencies, different technologies around it. There's AM, FM, DAB, which is digital, HD radio, which is quite common in America, I believe, and more. There is also metadata that is transmitted as well. There's different standards for that as well. And broadcast radio certainly comes with some unique challenges. Of course, it's real time. It's location dependent, which means if you got a broadcast tower, it only got a certain area, and when you approach the end of that area, you hopefully can still receive the radio signal, but at some point it switches to the next tower, and this has to use a different frequency. Otherwise, you would get the same frequency, but in different strength or different, maybe even time delay, and that would just be a mess, I guess. So there is this location problem and obviously moving cars. But what makes it really complicated is that there is so many different standards across the world. And it's not just across continents, it's even within continents, even local standards, be it different frequencies, different band spacing, other standards like what you're allowed to send or not. So I imagine if you buy a car in Europe, I wouldn't be so sure to expect the radio to work in America if you drive overseas with it. So to keep it a bit simpler, let's focus on just FM radio for now and just in Europe, right? And we get a frequency band from 87.5 to 108.0 megahertz with a 100 kilohertz spacing, which gives you the total maximum number of stations if you want to calculate it. And well, if you're building a radio and you want to scan for available stations and you want to tune to one station to play it at the same time, you actually need 2 FM receivers, right? One is playing the audio and the other one is scanning the available frequencies, waiting until it gets a signal that is good enough, maybe waits for the station name to be transmitted, and then just scans to the next. Modern radios usually have even more, maybe 3 or 4 FM receivers, maybe multiple DAB receivers as well. But my project I'm aiming for 2 FM receivers for now. And I want to use the radio data system. I want to use the program identifier, the program service name, and some other metadata. The program identifier can be really useful if you want to combine it with external data, which we do, for example, in the radio player app. And this here is my hardware setup. What I got is on the right side, the WIM3, on the left side, an Arduino Uno. They are communicating via the CAN bus, and I use an MCP2515 for that. And on the left side, you can see the SI47OX FM receivers, which use I2C. I am not quite there yet. The current status is I have only a single FM tuner. The Arduino scans for FM stations once after the startup and then just sends this list, whatever it found, every 10 seconds via the CAN. I'm simulating the next step that I expect my scanner to complete the scan within 10 seconds at least. I have no other features supported at the moment, so I can't tune, I can't play anything. It's just about getting my first signals from an FM receiver into my Arduino over the CAN bus into Android and displayed actually in user space in a radio application. It's just a proof of concept, and I think this is the point where I say, okay, I can say that's enough for me. It's a proof of concept. Everything else is just nice to have features. And yeah, I've only implemented the happy path, so no error handling anywhere. If I can't get it running, all I can do is just reboot everything. The hardware setup, why did I go this way? The CAN is a very common bus system in automotive. So I thought I will need it anyway in the future. I wanted to try how well the Android automotive support for the CAN bus works. There's also the Linux socket CAN available, which basically means the CAN is accessible via a network device and therefore can be accessed by multiple applications. And I really like the thought about having the Arduino deal with all the FM receiver chip thingies, because that would allow me to iterate a lot faster when I want to change anything in the behavior of the tuners. About the software, I'm using the WIM3 running Android Automotive 12 based on AOSP 12, obviously. No particular reason for the version 12. I could have went with 13. I was just pragmatic about it. I had 12 already downloaded, so I went with that. And on the next slides, I want to show you how the broadcast radio works, what the broadcast radio service is, what it does, and the challenges I was facing with the WIM3. Here we go. On the right side, you can see a graphic that I actually took from the Android automotive documentation. It displays nicely the layers. At the top, you got the radio apps. Then they access the radio via a system service, the radio manager. You can receive it via context get system service. And the radio manager again talks with the broadcast radio service. The broadcast radio service is started at a system startup by the system server. The system server is quite an important component in Android. It basically runs all the system services and maybe more stuff. It might be worth its own talk, actually. Don't want to go into too much details here. And at the bottom, you got the hardware abstraction layers here, representing DAB and FM modules. Now, I'm not using any for them for my implementation because I'm using a CAN, the CAN bus, and my Arduino is already doing everything. And I'm just sending the entire information over the CAN that maybe usually broadcast radio hub would do. So what I did is I added my own implementation to the broadcast radio service and used the standard CAN hardware abstraction layer that is available in Android. And when I did this, I actually had to kind of make a decision where I'm still not sure if it's the right way to go. So my thoughts were, do I want to implement the broadcast radio how? Because it's a hardware abstraction layer, so that my system service can just access my radio, which is a kind of a hardware detail how I implement radio, right? In the same way it can access other radio through the HAL, because that's what the hardware abstraction layer is, right? It hides the details of the hardware implementation. Or I take the approach that I actually took. I used the CAN HAL because it felt a bit weird to use one hardware abstraction layer from another one. And I'm open for feedback here if somebody got some strong opinions or not so strong opinions, maybe in the Q&A session. Let me know what you think about this decision. And what happens when you use this approach is the one that I took, not implementing the broadcast radio HAL, is all the seek, scan, step, and tune, all those functionalities. The implementation is shifted to the Arduino. And the CAN implementation, well, the radio service is just communicating with the Arduino, just telling it what I want to do. Now, the broadcast radio service, that's probably one of the biggest changes, at least in the amount of code that I made to the system. Number one, the broadcast radio service Java, which is the one down here. It extends a system service. It loads the modules and it acts as a proxy. And what I changed, obviously, is here you can see there is a HAL2 and a HAL1 already. And those two are referenced and started and managed in the broadcast radio service. And what I did is I just had a look at how is the HAL2 implemented and kind of copied the same behavior into my own CAN here and added that to the broadcast radio service. And the second bit is obviously the CAN broadcast radio implementation itself. The broadcast radio service listens for the CAN service to register at startup and then loads the radio module. The radio module provides information, number one, in the form of the radio manager module properties. This is information like, okay, what some hardware vendor information, like who implemented it, what version is it, and also what radio features are supported, what frequency bands, and etc. The radio module then opens a tuner session when it gets a request from the radio manager, and it brings up the CAN interface. That's my implementation of it. Brings up the CAN interface if it's not up yet. And the tuner session itself is doing most of this stuff. It extends the iTuner stub, which is again kind of related to the radio manager, and it communicates via the CAN. And yeah, that's pretty much that. Now, where to find what? It's especially for beginners, I find it always really complicated to navigate around the AOSP source tree. So here's a little overview where you can find the radio app, the radio manager, the service, and the how. I think it's self-explaining here. Now you probably wonder, okay, and how can I get there? How can I actually start those things? How can I get them into my build system? A very good example can be found in the device generic car common folder, the car makefile. This is just an example of an Android automotive implementation, right? But that's kind of the starting point. That's where you want to start if you want not just use Android, but Android automotive. And for the Vim3, I modified the device AM logic Ucala makefile. I added two files that I wrote myself, the car and the CAN makefile. The car contains basically the same stuff as in this example up here, plus the modules that I added manually. And also at the very last line, you might overlook it, it also adds the configuration from the services car product, which contains all the car applications, car services, and all that automotive related stuff. The CAN makefile basically is just, I also added CAN utils, very useful. It's Linux classes to test CAN services, basically. I mostly used CAN dump, which allows you to dump everything, show the log of what's going on your CAN. The challenges with the Vim3. So first one is it was quite poorly documented. And that might have been because when I started working with it, the documentation was just migrated to a new page. So in every forum, if you clicked on a link, it was invalid, and that was quite unfortunate. The AOSP kernel has no device tree configuration for the CAN on Vim3. And also it has no drivers for the GPIO interrupts. This was maybe the bit where I spent most of the time with. Luckily, there is a Ubuntu version already pre-built as well that I just flashed on the Vim3 at the very start to just test, can I actually access the CAN? And then the most of the work was just combining what I found in the source code of the Ubuntu builds and kind of pull that over into the Android kernel. What I had to change in the kernel, and I don't have enough time to go into the details here, but this I had to implement the GPIO interrupts. I had to modify the MCP drivers to get the CAN working. Bit of a weird hard-coded stuff in there. And I had to modify the device tree and the kernel configuration to actually enable those modules. Here's the device tree changes that I made. Again, I want to keep it a bit short. Here you can see that in GPIO, this is the custom property that was introduced by the manufacturer, I guess. There is some forum posts that are very confusing around this device tree. But so if you want to do something like that, feel free, get in touch, and I'll help you around with that. And now I hope we do still have some time for a little demo. This, what you see here, is right here to my right-hand side. I'm just gonna plug it in now. It will take maybe 30 seconds or so to start. I don't want to move it too much. What you can see here is my Arduino. These are the MCP chips that drive the CAN bus. This is the CAN bus, and here's the Wim3 on the right side. This little piece here, this is my FM module. And yeah, that's pretty much it. Let me show you something. So probably what could be interesting is this. Waiting for the device, still not doing anything. That's normal. Sometimes it just takes a bit longer to boot up. I don't know what's going on there.
Everything takes time in Android.
Yeah. Oh, and here we go. And what you can see here at the very top is that right when the system boots, this is really early, the drivers load. So that's what's going on up there. And I'll stop it here because that was actually already everything that we need to see. So first the drivers load, then the start broadcast radio service, the broadcast radio service is started, which means it's starting my own implementation. The BC Radio CAN server is my implementation. It gets the information that the CAN controller is loaded, and then basically starts everything, setting up the CAN interface. That went well. It's creating a tuner session, opens the tuner, and that's it. It even says CAN station list received. So if I maybe show you this as well. I told you about CAN dump, quite useful. Let's maybe wait 10 seconds, and this is what happens every 10 seconds. It's transmitting my own protocol of station list here. And to finish this, hope you can see this. It's
good.
Go into the radio app and browse, and here you can see the frequencies, and for some of them I'm even receiving station names. That's local radio in Vienna. And that's it. Thank you very much.
Okay, fantastic. Well, thank you very much. That was great. Okay, so open it out to the floor. Anybody have any questions for Simon?
Thanks for the V color flag for ADB. I didn't even know about that.
So, yeah, I'll just say one thing. So you said at the very beginning, talking about the Vim3, actually, is this still supported? So as far as I know, it is. It's still in the AOSP tree. And is anybody here from Bay Libra? Because Bay Libra actually do the support for Vim3 and Yukawa. No, nobody's admitted to it. Last couple of times, there have been a couple of developers from Bay Libra on board. So as far as I know, they're still supporting it. I don't know why the support page is gone. That's just Google.
Cool. Well, let's see what happens. Wait and see.
Hi, Chris. Hi, I have just a question.
Go ahead.
So thank you, Simon, for the presentation. It's very interesting topic. Actually, I am asking about the radio HUD is already implemented by Google in the releases, or why you just need to modify or re-implement it. I don't know why, because like I have working in the Android TV, and we face the same here. It's like same lack of implementation by the side of Google 3 years ago when we are using to scan from the DVB, from the OTT, to scan for the channel TV programs. So we are obliged to implement our tuner hard by ourselves to get from the hard to get the channels to be scanned to the TV provider and using the framework TV input. I don't know if it's the same case for the radio hard. I don't know.
Yeah, well, I mean, radio is supported by Android, right? Radio is, like I said in the beginning, a very complicated topic, and there is a lot of discussion around how it's implemented in Android as well, and suggestions to change various bits. I think this is, by the way, also the reason why the radio API is a system API, and not everyone can just use Android Studio to write their custom radio API, radio app, because I assume it will just change a lot in the future. So yes, radio is supported, but just there is a radio API. There is also an emulated HAL implementation. So if you just start the radio and add the radio HAL that is in there by default, you even see like a little list of stations that come out of nowhere. They are just hard coded, right? Basically, the Android team doesn't know what hardware you're using, so this is your job, the Windows job to implement the hardware abstraction layer.
Yeah, great. Because Google already, for our case, at the recent release in the, I guess, Android 12 and 11, they implemented for the TV a HAL called tuner HAL. So we don't need our third party, and we are using what Google did implemented already. So
interesting. Yeah, I mean, if there is a standard, obviously it's great if they are adding it, supporting it out of the box.
Yeah. Okay. Thank you very much.
Okay. Thank you, Ahmed. We have like time for one more question, I think. Does anybody want to ask a question of Simon? Hey, it's all gone quiet. Okay, well, if you do think of questions later on, feel free to put them into the Slack workspace.
I believe there are some questions in the chat.
There are, okay.
Oh yeah.
I've not been checking that myself.
Is the implementation presented on GitHub or anywhere? No, this is currently not open sourced. Like I said, it's a proof of concept. I did some things in a very hacky way as well. I'm happy to, if you're interested to see some source code, to share it with you or guide you through it, but it's nothing that I would like to release to the public, simply because someone could pick it up as the state of the art and follow my poor implementation. Second question here is, how is the load in the system when running the SDR? SDR, I assume, is software-defined radio. I just Googled that. How is the load in the system? Load on my system is it's insignificant. I'm using CAN to just receive messages every 10 seconds. There is not much going on. The CAN implementation is pretty much standard, and I'm just listening to that.
Okay, so thank you very much for that. The time is up, I'm afraid, Simon.
Thank you, Chris.
But I was going to say, if you have further questions, post them in the Slack channel, please, because the Slack will continue, whereas the Zoom chat will disappear once I shut down the Zoom session. Okay, fantastic.